Hi everyone! So today we're going to solve exponential equations where the bases can be made the same. Okay, so here's what we know. If your exponential function, remember, was y equals a times b to the x, if you have a b to the x situation and it equals another b to the something situation, right? If the bases are exactly the same, then your exponents are equal and you can go solve them. Okay? You always want to change the bases from a larger number to a smaller number. Okay? So let's practice creating some like bases. If I have 2 and 8, 2 and 8, how can I get them to all have the same base? 8 is bigger than 2, so I want to try and make 8 to have a base of 2, right? So 2 to the what power equals 8? That's your job to figure out and know. So I have 2, and I know that 2 to the third is 8. So 2 and 2 to the third. Now that I have these bases that are exactly the same, whatever the exponents were, I could set them equal to each other and solve. Okay? 81 and 243. Can I take 243 and see, like 81 to the what would equal 243? Well, 81 to the second power is 6,561. So there has to be a number smaller than 81 that I could rewrite these as. So down below, if you notice, I put this chart on here, and you only really need to fill it out if it will help you. Okay, so like that first one we had, 2 and 8. If I say the left column is my base and the top column is my exponent, like 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. So then when I had 2 and 8, I could figure out and look at my table. Well, 8 is the same as 2 to the third, and then I was given a base of 2. So if you fill this out, you would see like 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. So how can 81 and 243 become the same bases? 2 is a popular one and 3 is a popular one. So 3 to the what power is 81 and 3 to the what power was 243. Well, 3 to the fourth was 81 and 3 to the fifth was 243. Now my bases are the same, so I would be able to go and solve my problem. Okay? Looking at C, you have 5 and 1 over 25. Well, what's another way to write 25? Can I make 25 have a base of 5? 5 to the what power is 25? You guys know that 5 squared is 25. If it's a fraction, my exponent has to be negative. So 5 to the negative 2 gives me 1 over 25. Because remember, the negative would move to the bottom, and then 5 squared would be 25. So 5 and 5 to the negative 2 make like bases. So on that same note, how could you make 6 and 1 over 36 the same? I know 36 is 6 squared. So 6, and since it's a fraction, I'm going to have a negative exponent. 6 is the first base. 6 to the negative 2 would make the second number. Okay, 64 and 512. What do you know about 64? What's a common way to write 64? I know that 8 squared is 64. Is there a way to make 512 with a base of 8? 8 to the what power is 512? Does that work? We said 8 squared is 64. 8 to the third is 512. So that does work. So we have 8 squared is 64, and 8 to the third makes 512. Our bases are identical, 8. And if you want, go ahead and add that to your table. You know 8 squared is 64. 8 to the third is 512. All right, here's a little challenge. 101. What do you know about 100? I know that 10 squared is 100, right? Right? So if I make 100, that has a base of 10. So then 10 to the what power would be 1? If you guys recall, anything to the 0 exponent makes 1. So this would be 10 squared and 10 to the 0. Okay? All right, so this table, I'm not going to fill out the rest of it. You can fill it out if you need it, if it helps you. Okay? If you can't figure out how to make the like bases, use it. Okay, so now let's look at our first examples. We have 2 to the 4x and 32 to the x minus 1. Is there a way to make 32 have a base of 2? 2 to the what power is 32? I know that 2 to the 5th power is 32. And if I didn't know that, I could have checked. Well, I know 2 squared is 4. 2 to the 3rd is 8. 2 to the 4th. 2 to the 5th. If you don't know, you have to do a little game of guess and check here. So 2 to the 4x wouldn't change. 32, I could write as 2 to the 5th. And then my exponent given to me was x minus 1. If the bases are alike, then the exponents are equal. So then if this has a base of 2, that's 4x. This has a base of 2, that's 5 times x minus 1. Then go solve that equation. If I distribute 4x equals 5x minus 5, if I subtract 5x, negative 1x equals negative 5. Dividing by negative 1 gives me x equals 5. Okay, on the second one, 8 and 16. Is there any way to say 8 to the something equals 16? I know 8 to the first is 8. 8 squared is 64. So I can't make them have the same bases using 8. I need to go smaller. So we have to change the 8 and the 16. 8 and 16 are all multiples of 2. 2 is a common base. 2 to the what power is 8? 2 to the what power is 16? I know that 2 to the third is 8. So 2 to the third replaces the 8, and then I have an x. I know that 2 to the fourth is 16, and then I have 2x minus 1. If my bases are alike, then my exponents are equal. So 3x equals 4 times 2x minus 1. If I distribute, 3x equals 8x minus 4. Solving this for x, 3x minus 8x is negative 5x equals negative 4. Dividing by negative 5 leaves me with x equals positive 4/5. Okay, let's try another one. 9 to the 2x equals 1 over 81 to the 3x minus 2. What do you know about 9 and 81? I know that 9 squared can make 81, so the left side would stay 9 to the 2x. 1 over 81. I said that 9 squared can make the 81, but since it's a fraction, my exponent needs to be negative. So 9 to the negative 2 makes 1 over 81, and then I have 3x minus 2. Since I both have bases of 9, then I know 2x can equal negative 2 times 3x minus 2. 2x equals negative 6x plus 4. Adding 6x to the other side gives me 8x equals 4. If I solve this, I would have to divide by 8, and 4 over 8 reduces to 1/2. All right, last one. 25 to the x minus 5 equals 125 to the 3x minus 16. 25 and 125 both end in 5, so there's a good chance that they could be written as bases of 5. 25 is 5 to the what? Squared. 125, I know, is 5 to the third. So rewriting this problem, 5 squared is 25, and then I have x minus 5. 125 is 5 to the third, and then I have 3x minus 16. Since I made my bases identical, I can solve this. 2 to the x minus 5 equals 3 to the 3x minus 16. Distributing here gives me 2x minus 10. Over here gives me 9x minus 48. Solving this, if I subtract 2x, I have negative 10 equals 7x minus 48. Adding 48 to the other side gives me 38 equals 7x. And when I divide by 7, x equals 38 over 7. And that does not go in evenly, right? So x is about 5.4. Or 38 over 7. Okay? Just remember, make the like bases before you set the exponents equal to each other. Okay? I will see you in class next time. Bye.